All right, welcome back. So we are talking about things that are not C++. Excuse my cat. I'm sure you can probably hear him playing with his toy. So we were talking about Java. Java is a different language, but it's very similar to C++ still. Okay? And so we've learned a little bit about it, like the basic syntax, how to write hello world, declare some variables, kind of how it's doing its thing. But of course there's more to that. Let us learn a bit more Java by making a counter class. Okay, so we're going to make a counter class that's beautiful and it holds that count inside of itself. We'll make like a counter C, and it starts out at 0 maybe, then we say c.inc, and now it's counting up to 1, up to 2, if we say it again, so on and so forth. So let's get all this stuff in there and talk about the differences that we see when we implement this counter class, maybe in C++, versus when we do it in Java. Okay, so let us go over here and make a new file. Remember, if we want to call it counter, if we want to call the class counter, the name of the file has to be counter.java. Okay, that is key. We need that. All right, and then the first thing that we do is public class has to be counter. That's the name of the class that I'm making. And then if I ever want to do anything and print anything out, I need a main function as well. Okay, so I'll make my public static void main with the command line arguments is always required. You have to give this parameter to the main function. Okay, so it's a static function. It's not really part of any counter object. It just kind of sits on the side. That's the main function. The rest of the stuff that we do is part of counter, okay? Because main is static, it's not really a method that's part of any individual counter object. So we're going to make an inc method, for example, in a counter. Like there's no main method, it's static, and so it's slightly different, okay? That's the idea. C++ has static too, so let's write a constructor and like a Git Count method and an inc and a reset. How about that? Okay, so a constructor, it's all essentially the same as C++, though there's no like declaration and definition. It's just all in one. You got to define it. There's no separate thing. There's no such thing in Java as a function/method declaration. You just start going. You start right in the body. Okay, so the constructor is all very similar, but there's no such thing also as like the public colon as there is in C++. So what we have to do is we always say the access modifier next to the name of the method. Okay, so maybe I should put that up here too. You got to say that at the front of everybody. Okay, so like the constructor, for example, it's going to look like this. It's public counter. And then you can give all the arguments. Maybe you don't have any. And that's what it is. So let's make an empty counter. Okay. So we're going to need a field. Okay, let's make our field called count. We'll just call it count for fun. And it's a field, so normally in C++ we declare it as private, like that. In Java, we drop that and we say private out in front. Okay, that's just how we do it. So this is a private field. Okay. Isn't that nice? So now our counter, whenever we make a counter object, we're going to start its count at 0. There's no initialization list or anything like that. We just put it on in here, count equals 0. Okay? That's the idea. So every counter that we make now, its count will start at 0. And yeah, that's the idea. So we can make a Git Count method now to actually return back that count so that maybe we can print it in the main function. That would make sense, right? Like here's my goal. Here's the goal that I want to have down here. We're going to make a counter C, and remember that everything in Java every object is made on the heap, and so I can't just say this. I don't want to make it on the stack. I got to say counter C equals new counter. Call that that constructor very explicitly, and now I can print system.out.println. I can print C's count if I have a Git Count method. I can't say C.count because the count member variable is private. Okay, that is the idea. So yeah, right now it'll make the new counter, and the count gets set to 0 in the constructor, and it should print out 0. Okay, so remember how to do all of this. Oh, it looks like there's an issue. Cannot find symbol. Oh, I didn't make the Git Count method, did I? Let's do that. So it's a public method. We want everyone to use it. It's called Git Count, and it takes no parameters. Okay, so normally we'd make it const, but there's no way to mark a method as const in Java. There's no modifier like that. I should say very easily in Java. I think there's some ways to do it, but they're a bit fancy. So yeah, we're just going to return back our count. And now it should be happy. Okay? So this is, sorry, it's public int. It gives back an int. Public int get count, and it returns that integer count that is our member variable, our one member variable. So this will call the constructor, and it'll run, set the count to 0 for this C object, who is always made on the heap, remember, and then we'll print out C's count. Okay, so the way to compile this, again, is Java C, and then the name, counter.java, and then to run it, because it just made counter.class, you say Java, and just counter, no .class or anything, it just does it. Okay, and so it runs it, prints 0, and we are in business. So let's keep going a little bit. Let us do some more things. Let's say c.inc maybe a couple times. So now it should print 3. That's what we would like to have. So let's make the inc method. Okay, so it's public. We want it to do work for us. We want anybody to be able to call it, even outside the class. And it's a void method, and it's called inc. Takes no parameters. And what inc does is it sets count to be one more than it is. And ++ totally exists in Java. Okay, so inc, whenever we run that, it goes to our object, and it goes and increments its count. So there's no arrows, it's just all dots. Everything is a reference, even though we made it on the heap. Okay, it's all a reference. Java's version of references, that is. Recompile, rerun, and we see 3. Very nice. Okay, so what else can we do? Maybe let's have a reset method so that we can reset our value to a certain number, or to 0. Reset our counter down to 0, because we don't have a decrement method. Okay, so maybe we can say something like c.reset, and then c.inc twice, and then it should print 2, right? And then maybe let's make it so that c.reset has another option where we can be like, reset to 42, please. And then if we inc it a few times, we should print out 45. Yeah? So we should see 45 here, we should see 2 here, we should see 3 here, we should see 0 here. Okay, that's what we would like to see. So let's go and make this reset method. We're actually going to make 2 different ones. Okay? We're going to make 2 different methods for reset. One's going to take nothing, one's going to take the int. Okay, that's how you do it in Java. So reset, again, it's public. It is void, it doesn't return anything, it just does something. And it's called reset. The one with no parameters, let's have that reset it to 0. And so we're just going to set count to be 0. Okay, so that's one reset method. That's the one that's parameterless, or parameterless, argumentless. We can also make one that takes an int parameter. We'll make a separate reset. So this one will take the int, new count maybe, and we'll reset the count to new count this time. Okay, hopefully you're all following this. This is not too bad, it's just slightly different syntax, right? That's all it is. And so we'll reset this count to be new count, and yeah, that should do it. So let's go ahead, compile and run this and see if we get the output that we want to see. Java C to compile, to remake that remake that counter.class file, and then we say Java counter to go and actually run the thing. And oh man, are we actually printing the stuff that we want? Look at us, we are awesome. So that is that's the idea. That's a counter class. So we've noticed that we have to put public and private, unfortunately, next to everything. The next thing that I want to talk about is operator overloading. Sadly, that's not a thing. We cannot have like make it a second counter C2. We can't be like, okay, if that has the count of 2, we can't say something like C plus C2. We can't override the plus operator in Java. We'll have to instead transform this into, we're forced to use something like C.add C2. It's a bit uglier, but that is what we get. So let's work on making an operator that is like the .add method that works kind of like what operator plus we would want it to do in C++. Okay, so let's make that operator now. All right, so we're going to add a .add method. It will act like operator plus. So .add will look like this. You'll say like C1 .add C2. Oops. C2, and then it will go and add the counts from one to the other. Okay, and maybe it'll return a new count. A new counter, actually. So how about, it's got to be a public method because we want to use it like this, right? Here's the idea. We'll have another counter, C2 equals new counter, and maybe it holds, I don't know, it'll be like C2.inc. Maybe it holds 3. So we want to make a third counter equals C.add C2. And when we print its count, we should be able to see, if we do C3, we're like adding one counter's count, C's, to another counter's count, C2's, we should get back the 45 plus 3, so the count should be 48. Yeah? That's what we would like to have. So this .add method should return back a new counter. And it's public, we want to use it in main. Public counter, and then add, and we give another counter. And it's just, everything in Java is a reference, so you don't have to say ampersand, you don't have to say star, you're just getting that thing as a reference, always. Counter, other, we'll say. And so what we want is, okay, we start out with the counter that we currently have, because we're always, when we call a method, we're inside of somebody. We will be inside of, I guess, C. We're acting on C right now when we say .add with a C2. So we have our own count, okay? So int sum count should be our own count plus the other's count. Yeah? That's the key. And then we want to make a new counter that has that count. So we'll say counter, I don't know, ret for the counter that we're about to return equals new counter. And then we can immediately reset its count to be sum count. That was a useful method to have, wasn't it? Okay, and then we just return that ret, which is the counter that represents the sum of our current selves and then the other counter. Yeah, that should do it. And I think that is enough to get us to 48. Let's see. Yeah, look at us. Okay, so that gives us a count of 48, and we have come a long way here. We've talked about all the little different parts of making a class in Java. We have fields as normal. We just have to say access modifier before them and their types and their names, and then same for constructors and methods. It's always public, public, public. If you want a private method, you gotta say private. You have to say it every time That is the key. We were sad about there not being any operators to overload. Oh well. And every time I said new, I never had to deal with pointers. Every time I wanted to pass a counter, I didn't have to worry about using references or pointers. In Java, everything made on the heap is just immediately called a reference, which is slightly different to our own C++ version of references, where you can use the dot immediately. Okay, no copying takes place. It's under the hood, I guess, secretly passing along pointers, but we just use dot in Java. It's weird, but hopefully makes a little bit of sense. So yeah, that is a counter class. Please yell at me if you have any questions about this stuff. It's fun. And yeah, so let's just give one last run through all the significant differences between Java and C++. Thank you to Bill for these slides. You should definitely take some of his classes. Okay, so Java versus C++. Java is not really compiled into machine code. It's compiled into this Java virtual machine bytecode thing. You don't have to worry about that until you take an upper division class on compilers maybe, but there's something going on under the hood in Java. You have to run it on a special thing called the JVM, Java Virtual Machine. You can't just immediately say // and expect it to run machine code. Java is not technically a compiled language. It's an interpreted language in a weird way. It compiles halfway, I guess we can say. Okay? There's no const in Java. Instead, if you want like a global variable that's visible to everybody, like you would put outside of any function / class in C++, instead you'd say like public static final. The final part is the part that's saying it can't change. That's their version of const. Char doesn't exist in Java. Instead, they have byte. And this actually kind of makes sense because every char in C++, it is 8 bits long. It's 1 byte long anyway, so they just use that word instead. And yeah, no pointers at all, even though it might be working with pointers under the hood. It does it all for you. It uses references, and you don't have to say anything special. No ampersand, no nothing like that. That is Java for you. No operator overloading, so you cannot overload an operator. You got to say like .less than if you wanted to have this one, for example. Yeah. If you want to include a library, I'm about to show you that in the next example. You use import rather than # include. Okay? So we'll talk about how to include libraries. And this is something that's probably more of a CSCI 41 topic, but it's good to know now. Remember how I was talking about how every IF stream, it inherits from, it comes from an I stream, it is an I stream. And that's kind of where it ends in C++. In Java, every single class you make, even like counter, it inherits from something called object, some very generic class. It's called object, and it gives you some nice special things. Okay, so when you learn about inheritance in CSCI 41, come back to this, because every class in in Java inherits from this special class called object. Some nice things about Java that we don't really have in C++, though C++ is getting better. Compilers are better at warning you about things, hinting to the compiler that you want certain things, and there's a nice automatic documentation system called JavaDoc, and that's the reason why all these cool websites, like this one, they can be generated automatically from the code. And so it can go on Oracle's website, and you get to see what's going on there. It's quite nice. And what else? Yeah, we don't have to ever say delete anymore because Java has what's called a garbage collector. It just calls delete for us once it notices that we're done with that class, with that object. Okay? And the standard library, oh man, I've shown you a few things. Look at all of it. Like, there's no way you have this much to scroll through on the C++ documentation website. The Java standard library is amazing. It is the stuff of dreams. Okay? So a lot of stuff has been pre-implemented for you. One thing that we definitely don't get pre-implemented for us in the C++ standard library is having to do with graphical user interfaces. We're finally going to make some programs. Unfortunately, they have to be in Java. Sorry. that have a graphical user interface. So it has a window, it pops up with a new window, it has some buttons to click, it's all fancy and cool. We're going to do that now, okay? So we're going to have a little crash course on graphical user interfaces, or GUIs for short, okay? That is the whole idea here. And so the library, the part of the Java standard library that handles at least one of them, they have several different kinds of GUI libraries. One is called Swing. It's the easiest, so we'll talk about it. It's part of the JavaX package. Inside of that, they define the Swing library, okay? And so, yeah, here are some examples. I encourage you to read this stuff if you're interested, but I'm going to give you a nice example of, we're going to actually make a GUI around our counter class, okay? So we're going to have like a window, and we'll have like the count displayed or something, and then we'll maybe have like an ink button, and we can click it and make the counter show 1 now. Isn't that cool? So we'll do something like that, okay? That is the hope. And so yeah, GUI just stands for Graphical User Interface. It's short for that. And we're going to use the Swing library, okay? The Swing library has a bunch of what's called components pre-made for us, like a button, like a little text field, like a little window, all that stuff. That's going to be what we're going to use, okay? We're going to use the Swing library, okay? So let us do it. Without any further ado, we're going to make a graphical user interface around our counter class. So at the end of the day, we have a window being displayed, but under the hood, we're going to be using our little counter class that keeps track of like what should be displayed. Yeah, and when we press the ink button, it's going to call the ink method and then update the display with the new Git Count value. Okay, that's the whole idea there. So, yeah, let us do this. Let me make a new file called counter-GUI.java, and what I'll do is, of course, we have to say public. The class name has to be counter-GUI now. Public class counter-GUI, and that is what we need to make. It's going to have a main function, of course. So let's get all that boilerplate out of the way. But first, we need to include this fancy Swing library, okay? With all its nice things. We're going to include it so that we can use stuff like, where is it down here? Class summary. All the stuff that starts with J's. So that we can use things like JButtons. If we make a JButton, that makes a button that we can click. Isn't that cool? So that's what we're going to do. We're going to import this package. Okay, it's not include in Java, it's called import. So we're going to import javax.swing.star. Star stands for everybody. Every single thing in the Swing library. We're going to import it right now. Okay? And then there's another piece that we're going to need in a second, so might as well get it ready. Import java.auth.event.star. I encourage you to look up this stuff. I don't have enough time to explain it all, but that is the idea. So this is Java's version of include. So now we've included these libraries. Quite nice. And then we are going to make our counter GUI, which under the hood uses a counter. Okay? That is the hope. So we'll use a counter under the hood to keep track of our GUI's data, because it needs a count somewhere. Let's just save it in a counter. How about that? So because I'm going to do stuff from main, I don't really need to make any extra classes. Let me make a static variable. We'll call it we'll make it private, because why not? Private static counter C. Okay, and we'll give this, we'll create it in the main function. We'll say C equals new counter. So now we start our count at 0, and that is what we will use to get the ball rolling and all of our windows made. They'll start out with a fresh counter with a count of 0. Okay, so now we're going to use the swing library stuff. Okay, the very first thing we need to make is what's called a JFrame, which keeps track of a window. It makes the window for us, and inside of that frame we can add buttons and things. Okay, so JFrame, I don't know if there's going to be any good examples down here. It doesn't look like it, but just take my word for it. This is your window. Okay, it is a window. So we got to make one of those so that we can put stuff in the window. Okay? All right, let us go back to the code and do this. So let's say JFrame, because we got to make one. Let's just call it frame, because why not? That's a easy name. And we say new JFrame. Okay? And its constructor takes the name that you want to have on the window. Just like every window up here, like this one says terminal nvim counter.java, our window has a title. We can give it a title. Counter GUI or something. Okay? And yeah, a JFrame is a window. And that's the title of the window. And for some strange reason, we also have to do this. We have to say frame.setDefault close operation, because otherwise it's going to do something weird. JFrame.exit on close. Sorry, this is just magic probably, but this is telling it to, okay, whenever we press the X on the window, please stop the program, because otherwise it would maybe just minimize it or something. It has a weird default, so we're going to change that default to something normal. Just stop the program, please, when we press that exit. And then we can give it stuff. Okay? Now we put stuff in our window. And because we want multiple things, we need to arrange those things. We need something to hold all that stuff. In order. So we use what's called a JPanel now. And that constructor takes no parameters. And so the idea is, here's our window, here's our frame, and then inside of the frame we're going to have a panel, and in that panel is where we can put like buttons and little text fields, things like that. Okay? That's the idea. So let's see if they say anything nice about JPanel. Just a generic lightweight container. That's very helpful, isn't it? So yeah, we're going to make one of those. And now we can start putting stuff in the panel, like this display that's going to show our count, right? We're going to need that. So let us make what's called a JText field. It's going to hold text. It's a field that holds text. Here's some examples. Let me show you how to read this kind of stuff. Where is the constructor? Dun, dun, dun. We're going to call this constructor on JText field because we want to have at least three columns of width for our display. Because maybe we'll have like in the hundreds of counts. Okay, our count could get super high, and we want it to be able to be displayed. So we're going to make a 3-column JText field. I've discovered that's a good number. Okay, so JText field tf equals new JText field, and we're going to give it 3. So we want 3 characters wide. And a JText field lets you display text, which is super nice. And we're going to put stuff in this field ourselves programmatically in code. We don't want the user to be able to type in this, okay? Because it is just like a text field. Like this program that I'm writing is technically one big text field, right? So we're going to say tf.setEditable false. We're going to make sure that the user can't type in here. We'll put a value in it ourselves. And so I think the documentation might tell us some stuff about that. Set editable. Dun, 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 there it is. And so you can say set editable with a Boolean value, and it indicates whether this thing that we're making should be editable by the user. And we don't want it to be. All right. So now, let's give it some text, right? We got to put something in it. So let's say tf.set text to be a number, okay? We want it to hold whatever our counter holds, so like c.get count, right? And unfortunately, text fields can only hold strings. This is an int, right? We got to convert that into a string. So let's do that with a library method called integer.toString. It's just a different standard library. All this stuff you know how to do in C++. It just has another name in Java. That's all. So we're going to set it to our initial count, which should be 0, right? We haven't clicked on anything. We haven't changed anything. And then I'm going to set the font size as well. Let's see here. Set font size. That one's not a method for some weird reason. TF. And we're going to make it size 32. That's big enough, I think. Okay. The small default is not good enough for us. Yeah. So, give it the value of our counter. Yeah. And then make the font huge. I think that's good enough for now. And let's see here. What is something that we should do here? First of all, set font size is something I have to go and implement. I probably should have just made it before I started this program, but let me just show you what it needs to be. I'm copying this for my notes. I'm not this cool. We have to say, okay, for this component, we want to set its font to be whatever its current font is, changed a little bit, giving it a new size, and apparently it takes a float instead of a double, which makes no sense at all. Now we have set font size. Okay, so we want to add this text field to our panel, right? Let's do that now. We'll say panel dot add tf. Yeah. And then we want to add the panel to the window, because they got to go inside of each other like this. First, the text field inside the panel, inside the frame, which is the window. We will say frame dot get content pane dot add panel. Bunch of weird library functions, but they're doing the job. This is adding to the window, which is the frame, our stuff, all the stuff that we put in our panel. And then we say frame.pack. This tells the window to resize itself to fit the contents that we put in it. Otherwise, it might be very small or very large. And then we tell the window to show itself now that we're ready for it to be shown. Set visible true. And unless I made any horrible mistakes, this should display text field with 0 in it. One nice thing about Java is this is the standard library we're importing. We don't have to worry about importing counter because it's in the same folder. And Java notices it. So that's nice. Okay, so the idea is we have this counter that is keeping track of all our stuff, and now we're going to make a window based around its data and changing that data. So we're going to make a new window. We're going to make a panel that holds different components, parts of the window, like a text field. That's the first thing that we made. We added it to the panel, and then we made the panel accept that stuff and put it in the window, told the window to resize itself, and told the window to then show itself. So please ask as many questions as you would like. It's fun to talk about this stuff. It's cool. Let's run it. This is counter GUI, isn't it? Oops, sorry. There we go. And so we have two class files now. One is the counter's compiled form, one is counter GUI's compiled form, and one uses the other, right? All right, moment of truth, guys. It takes a second, but there's our window. Look at it. It's resized to be small because that's the size that our text field has, but we can resize it if we wanted to. If only I can grab it. There's a way. There we go. See, it has counter GUI. It has a text field with 0. We cannot click it or change it. I can highlight it apparently, but that's about it. That is our program. When I click the X, program stops. Isn't that cool? Isn't that super duper cool? Okay, so let me check our time, make sure we're doing okay. The next thing that has to happen is we have to add the other stuff. Let's make a button that increments. We need an increment button, don't we? Let's do that. Let me go back to my notes and make sure I'm doing this all right. Okay. So let's make an increment button. All right. J button, that's its name. Inc for increment equals new J button, and then we give it a name, something that's going to be displayed. Increment. Okay. And now we have a button. Isn't that nice? We can add it to our panel. We can say add inc. You know what? We should make a reset button too. Why not? And we'll add that to our panel. That'll be cool. We should probably set its font size to be large. The same size as the others. Inc and reset. Please have large fonts. And what do you think happens when I run this? Compile it and run it. Look at me. Look at that. So got a window, it's got a text field, it's got two buttons, increment and reset. But when I click them, they do nothing. I have to give some functions for them to call when I click them. They need to know what to do, and I've made them physically, but I haven't given them a purpose yet. They don't know what they're doing. They just exist. Okay? So that's what I needed this for. Java.auth.event. Because it needs to figure out when it's clicked and then do something cool when it's clicked. All right, so here's how you do it. Now we need to set up a click action, okay? It's called an action, that's the technical term. It gets performed, that's another technical term, whenever the button is clicked. So here's how you can do it. You can say inc.addActionListener. It's a long word. Java's really known for long words in their programs, in their libraries. And so we'll make a brand new action listener. And this is secretly a class, but I can define it on the fly. It's really cool. Public void. I'm making a function inside of a function. It's odd. I know. Action performed. And then it's action event, EVT, that's just a name. So every time inc has an action that's been done, which there's only one action to do to a button, that's click it, it will secretly call this function that I'm defining inside of the main function, which is odd. It should make you a bit anxious, but that's okay. It all is going to work. What we want to do in this case, whenever the button gets clicked, is, this is inc, right? We want to update our counter. We want to do, what's it called? What are we calling our counter? Is it just C? Yeah, we're using C. So we're going to say c.inc. Okay, we're going to increment that counter, and then this has incremented the counter, but it hasn't changed the text that's being displayed in the text field. So we're going to have to reset that. Yeah? We'll just do that same thing all over again. Just set its text to the current count in C, because after we changed it, it's going to have a new count. Okay? So that is what we want to happen whenever the ink button is clicked. Increment the counter itself, that's like storing the data behind the text field, and then go and set the text field to that new data. Okay? Compile and run that. Oh, yeah, look at that. Isn't that satisfying? Now all that's left to do is reset, and it has the same style. Okay, it's all pretty much the same. We want something to happen when the reset button is clicked, so reset.add action listener. Whenever that happens, we're going to reset the counter. And then obviously the text has changed, or the counter's count has changed, so we should change the text of the text field. That's supposed to always display the updated count to whatever it currently is. Okay? That, my friends, I think is all. So in the end, we got to make a counter. That's like our backend. That's our database. Let's say that. And then we made a window to put stuff in. A window, if you want the window to have multiple things, you need to arrange those multiple things, those text fields, those buttons. A J panel is one way to do that, so we used that. And then we made a text field, put it in the panel. We made a button, put it in the panel, and another button, put it in the panel. All right there. We told those buttons what to do when they were clicked, and we always remember to set the text field to the most recent information from our little counter database. And then finally, once we were done setting everything up, we told the panel to add itself to the window. We told the window to resize itself to the to just hold everything, nothing more, nothing less, the perfect size. And then we told the window to show itself. Okay? That is it. That is it. Just a nice little helper function that makes fonts bigger. This should be our counter. And look at how I don't have to recompile counter, because that never changed. It's just counter GUI. Okay, so I've got a window. I've got counter GUI as the title, I've got a 0, and I've got an increment and a reset button. Increment works when I press it, it runs this method. It increments the counter and resets the text in the text field. And then reset does the same thing. It resets the counter and sets the text back to 0. Increment a little bit, reset. Increment a little bit, reset. That is it. Isn't that cool? This is quite satisfying, I think. So that, I think, is all I want to show you of Java. There's obviously plenty more. The rabbit hole goes deep. The libraries are enormous and plentiful. So yeah, look around if you are interested. I'd be happy to talk to you about Java during office hours. Yeah, it is very similar to C++, but slightly different. So now you are experts at Java, and that is a good place to stop this lecture. When we come back next time, we will talk about Python, and I will teach you a little bit of Python. So you will have learned 3 languages by the time you're done with this class. Isn't that nice? So yeah, I will see you in the next lecture, and we will talk about Python there.